Hello everyone, I'm going to give a walkthrough of the Tesseract Ignition Tesseract Setup Wizard. To begin, if you followed the link from the blog post, it should bring you to this page. The first step is to click Install. Then copy this command down here into the terminal, paste it. It will then install the Tesseract Ignition applications. Once you've done that, you can then navigate to your terminal. The first step is to source your workspace. Next is to run Tesseract Ignition Tesseract Setup Wizard. So this will run the Setup Wizard. Once it's up and running, your next step is to browse to your URDF. If you have an existing srdf, you can load it here. I'm going to go ahead and do that. If not, that is fine. You don't need it. Once you've either put in URDF or both your URDF srdf, you click load. It will load this environment. What we're currently loading is the Tesseract ROS work cell. It's an example repository showing how to put together a scan and plan application leveraging Tesseract. So we have a 6-off manipulator with a 3-axis positioner with a section of the fuselage and a push corp, spindle, and compliance device leveraging an ATI tool changer and a docking station. So the next step is there's a few ways of navigating the different pages of the Setup Wizard. You can come up here to the 3 dots, click there, it'll open up this side pane so you can navigate to the allowed collision, kinematics groups, user states, TCP, OPW kinematics. Go back to load. The other option is this is a slider pane, so you can just swipe through the different pages back and forth to get to it. So the first step usually is you want to generate your allowed collision matrix. As you can see, one is already populated here. This allows you to define the number of random states sampled. The max is 10,000, defaults to 8,000, and it will go through and generate pseudo-random joint states and check for collision to help determine things that are always in collision, never in collision, or adjacent. Also, if you go through here and you find out that it's determined something incorrectly, you are able to click on it and select remove, and it will delete it out of the allowed collision matrix. Once this is done, your next step is to create your kinematics groups. As you can see, I have 3 already defined, one for the robot, one for the positioner, and one for the push corp compliance device. So we're going to go ahead and remove the robot only and recreate it. So give it a name. You can define them as a chain, joints, links. So we're going to start off with chain, robot base link, robot tool 0. And you add it, and it adds it to the list. After you've done that, you have the ability to create user-defined states. So we're going to do this. We're going to create some states for the robot only. Let's call it home. And let's change joint 1 so it's over here above the tool changer. So once you get there, you can add it and save it. And you can see it shows up here. If you don't like it, you can click remove and readjust it and do it again. Another option is creating group-specific TCPs. So we're going to go ahead and do that. We're going to create a robot only. Let's give it a sander and go through and fill out what this should be. And once you're done, you add it, and it shows up down here below. So, and the nice thing about this is that it allows you an easy way of switching out the TCP without actually having to go in and add links to the URDF and do things like that, which is common when you're constantly calibrating and tweaking things that you don't want to have to go through and update your URDF. You can just easily configure the srdf TCPs. And the full Tesseract planning framework supports these. The next step is if you had a manipulator that was capable of leveraging the OPW inverse kinematics, you could define those here by selecting it, filling out all the information and adding it to the list. And those are all the different pieces. The next step is we've kind of got it all filled out. We'll go here back to the load page and let's save it. I've done this a few times. Let's save it as the third version. Save it. And we will open it up and just take a look to see the new content that has been added. Bring it over. So you can see here, work cell test3.srdf is what we exported. And you can see we've got the robot only, which is a chain manipulator group. We can see our robot only home position that was created, where it's all the joint positions. Joint 1 is 1.53 negative. You can also see the TCP that was created for group robot only of name Sander. Point 1 on the Z. Default saves everything as quaternions. If you're doing this manually, you can type in and do RPY. That is fully supported. But everything is exported as quaternions from this. And then you have your left collision matrix. And that's it. If you have any questions, feel free to create issues on Tesseract Ignition. And thank you for your time.